Welcome to lesson 3.13. We're going to continue writing rational equations, but we're going to expand our horizons by looking at a different type of real-world situation. So to get started, let's go ahead and work through this problem. I want you to try this on your own. You don't need to spend time copying all of this down. All you should do is label discovery problem, write down the header, and then label A, B, C, and D with your answers fully written out and explained. Okay, so let's take a look here. The first one is pretty simple, and I've drawn a picture here to help us illustrate. But 2 liters of juice and 8 liters of water, that's going to make 10 total liters of lemonade. So now when we think about the percentage that is lemonade, we can reference our picture here to make sure we're using the correct fraction. So I want to know what percentage out of the total is pure juice. So I'm going to take the pure juice, which is 2 liters, and it's out of the total amount of lemonade. I might be tempted to put 8, but really the total amount of lemonade is 10. It's 8 plus 2. So this here represents the amount of pure juice, and this here represents the total amount of liquid. This will give us 0.2, which is equivalent to 20%. Now this is what we call the concentration. So if I were asked, what is the concentration of pure juice in your 10 liters of lemonade, you would say that it's 20%. So now what if we add 1 more liter of juice? So the easiest way to do this is to look at our drawing here and to say, okay, let's imagine that this part that's pure juice, that we poured 1 more liter in. So instead of redrawing the picture, let's just represent that with a 3. Now I might be tempted to stop there, but remember, not only did I increase the amount of pure juice, because I did that, I increased the total amount. So when I compute the concentration this time, I'm going to end up with 3 over 11, which is 0.27 repeating. And so I will say the concentration of lemon juice now in the lemonade is 27%, where before it was 20. All right, so now we want to take this and generalize it. Suppose we didn't add just 1 liter. Let's suppose that we add X liters of juice to our lemonade, the original that we had from part A. We want to write a rational expression that would compute the concentration of pure juice for any value X. So C is going to represent concentration, and I want to write an expression that will give me the concentration depending on what X is. So as we can see, what we did is we took the value of X and we added it to the number of liters of lemonade that I have already in the mixture. So it'll be 2 plus X. And remember, that is out of the total amount of liquid. And since the total amount of liquid to start with was 10, I'm going to have 10 plus X. Now, I can see how I'm able to write an expression that will actually give me the concentration, and I can see what this would look like by graphing this function, obviously, what the concentration will do as X increases, and I can compute the concentration easily for any value of X. Let's go ahead and define clearly concentration again and talk a little bit more about it. Concentration is not that hard to comprehend. I'm not talking about the concentration in the sense of concentrating on a movie or a book or something like that, but rather the concentration is the relative amount of a given substance, and in this case, in our discovery problem, it was the lemon juice, within a mixture or solution, the lemonade, or it can be within a given space, right? Maybe I have a certain amount of oxygen in a room or something like that. So a couple of things to note. Concentration is computed, right? How did I compute concentration? I divided the amount of the given substance, so that was the lemon juice, by the total amount of mixture or space. And this is always going to give me a decimal. And what's the decimal going to be between? Well, I want you to think about this for a second. Remember, I'm always going to have at least 0 of that substance. So the very least I could have would be 0. And what's the most I could have? Well, the most that that substance could take up would be the entire space. So even if the substance was exactly the amount of the total, that would still give me 1. So it's going to be between 0 and 1. And of course, when I get a decimal between 0 and 1, I can interpret that as a percentage, right? So for example, 0.5 tells me that 50% of the solution is, in that case, the pure lemon juice. So the way I might represent this is, in general, the concentration is computed by taking the amount of the pure substance and dividing it by the total amount. And as we saw in the discovery problem, the way that I compute the amount of the pure substance and the total amount can be connected, right? I might be adding something to the mixture, and so I'll be adding a pure amount, and I'll be adding to the total amount when I do that. So that gets me to the last point here, which is when computing, you need to be sure to remember that adjusting the amount of the pure substance also changes the total amount. So I should probably add the word pure here. It will also change the total amount, so I need to be careful of that. All right, let's go ahead and try a problem now, now that we have a better understanding of what concentration is. Okay, so before you get into this problem, remember what your protocol is. You want to go through, read the question, make sure you understand what you're trying to find, and make a plan for doing so. So go ahead and copy this problem down, go through it once on your own, and then press play and we'll talk about it together. All right, so a simple enough situation here. I have 20 ounces of a solution, and inside there are 6 ounces of acid. And I'm planning to add some acid to the solution. So the concentration of the solution is definitely going to depend on how much I'm adding, right? I have 6 ounces in there already, and if I'm adding, that amount that I add is going to determine what the concentration happens to be. So I'm going to write a function for the concentration, C, in terms of the amount of acid, X. So this tells me here that C is going to be the dependent variable, and X is going to be the independent variable. And I remember, of course, just looking back at my notes, that concentration is determined by taking the pure amount of the substance divided by the total amount. So the pure amount of substance, well, I have 6 ounces already, and I'm going to add X. And then the total amount, well, in the 20 ounces, so I have a total of 20 ounces, this tells me the total amount, then I'm going to have 20 plus X. All right, so there's my function. All right, so now I'm going to go ahead and compute the concentration when I'm adding 5, 10, and 20 ounces. And so here's my computation, C of 5, C of 10, and C of 20. And I can see here that I'm going to get a decimal, and I'm going to convert that to a percentage. So my concentration when I've added 5 ounces is going to be 44%. When I've added 10 ounces, 53%. And when I've added 20 ounces, it's going to be 65%. So now the question is, how much acid needs to be added so that exactly 50% of the solution is acid? And this could come up quite often because sometimes you know exactly how much of a certain chemical is safe and how much isn't. And so you don't want to just find out, what the concentration will be. You want to say, I need the concentration to be something. Let me find out how much acid I should add. So in annotating this question, how much acid needs to be added? So here I know that I'm looking to find the value of X, so that exactly 50% of the solution is acid. So this tells me the value of C, it's going to be 0.5. And so now I can go and I can actually use my equation that I've written to solve this situation here. So I have 0.5 is equal to 6 plus X over 20. Plus X. And this is easy enough to solve. I simply need to multiply on both sides by 20 plus x, and then I can solve for x. So go ahead and show your work here. I expect to see your work and then check your final answer that it makes sense. So I'll be looking here that you have the correct value of x, and then you can check that x is correct by plugging it back in and seeing that your concentration will be 0.5 or 50%. All right, last but not least, I want you to answer E on your own, and I want you to give evidence here. So I'm looking for 2 to 3 sentences at least agreeing or disagreeing with this statement. If you add enough acid, you can reach 100% concentration. Explain your answer and use your equation to support your reasoning. So you should talk about how your equation tells you why you should agree or disagree with this statement. All right, go ahead and complete that, and I will see you guys on Monday.